Today, we're going to explore the Monty Hall problem, a famous probability paradox that challenges our intuitions. It's often misunderstood, so by the end of this presentation, you'll have a clear understanding of the math and why the counterintuitive solution works. Firstly, let's look at what the Monty Hall problem is. It is a probability puzzle based on a game show scenario. In this scenario, there are 3 doors, behind one of which is a car, and behind the other 2 are goats. Your objective is to select the door with the car behind it. You pick a door, and Monty, who knows what's behind each one, opens another door to show a goat. He then asks if you'd like to stick with your original choice or switch to the remaining door. The key question is whether you should stick with your original choice or switch to the other door after Monty reveals the goat. Many people's intuition says it doesn't matter. After all, there are 2 doors left, so it seems like a 50-50 chance. But math tells us something different. Surprisingly, the best strategy is to always switch. Here's why. When you pick a door initially, you have a 1 in 3 chance of choosing the car. But if you switch after Monty reveals a goat, your probability of winning increases to 2 of 3. The math behind seems strange, but it's a result of Monty's actions, knowing what's behind the doors, which impacts the odds. Before we go through a breakdown of the probability, let's have a quick look at the background of this problem and how it gained notoriety. In 1975, a letter written in Mathematics magazine by Steve Selvin, a statistician at the University of California, Berkeley, sparked significant debate within the mathematical community. Selvin's formulation of the problem suggested that a contestant's best strategy would be to always switch their initial choice after Monty reveals the goat behind one of the doors. This would give the contestant a 2/3 probability of winning. This seemed counterintuitive to many, as they felt the game should be a 50-50 proposition after Monty opens one of the doors. Selvin's analysis showed that this was not the case. Furthermore, the problem gained mainstream recognition in 1990 after the author of Parade's magazine Ask Marilyn column, Marilyn Vos Savant, received thousands of letters from her readers who were baffled by the result. She went on to explain and show mathematically how the solution worked and probability would be increased by switching doors. Now let's look at a breakdown of the probability. From making an initial choice, to Monty revealing one of the goats behind one of the unchosen doors, to finally deciding whether to stick or switch from your original choice. When you first pick a door, there is a 1 in 3 chance that there is a car behind it. By Monty revealing a goat behind one of the unchosen doors, he's providing you with new information. If you stay, you're relying on your original choice being correct, which happens to be 1 in 3. But if you switch, you're more likely to win because Monty's reveal of a goat helps you narrow down your choices, and it turns out the odds of winning by switching are 2 in 3. Based on this information, you're twice as likely to choose the car when switching than you would be to stick with the same door. Now let's look at real-world application. The Monty Hall problem isn't just a theoretical exercise. Its core ideas can be applied in real-world scenarios ranging from business strategy and medical decision-making to consumer behavior and machine learning. The key takeaway is how new information can dramatically alter your decision-making. It is often more beneficial to switch once additional data has been revealed, whether that data comes from competitors' actions, a test result, or market conditions. Here we have 2 examples: decision-making and uncertainty, business strategy and risk, and game theory and competitive strategy. In business, decision-making is often done under uncertainty, where leaders must choose the best strategy without knowing the full picture. Much like the Monty Hall problem, initial choices might seem optimal, but new information like market shifts or competitor moves can reveal better opportunities. By updating strategies based on this new data, businesses can improve their chances of success, just as switching doors in Monty Hall problem increases your odds. In game theory and competitive strategy, companies must make decisions not only based on their own strategy, but also considering the actions of their competitors. Similar to the Monty Hall problem, companies often face situations where new information, like a competitor's move, forces them to reconsider their initial decisions. Switching strategies in response to this new information can significantly improve a company's position just as it does in the game show scenario, where switching doors boosts the probability of success. In conclusion, the Monty Hall problem is a great example of how probability works in counterintuitive ways. Whether in business risk management or competitive strategy, revising your choices when new data emerges increases your chances of success. Understanding when to switch in the face of fresh insights is crucial for achieving optimal results in both games and real-world scenarios. Thank you very much.